So in this video, we're going to be discussing what is the segment addition theorem and how do we use it. So let's first talk about how do we find the length of BC on this number line. All right, so basically, right, you can count, or if you know that C is on 3 and B is on 1, you can just subtract 3 minus 1 and you have 2. So the length of BC is 2. And this is what we would do if it's like obviously a bigger number that's not just countable. So now let's go ahead and apply that to this number line right here. So we're trying to find the length of AB. So again, I would do 1 minus negative 2, which is just 1 plus 2, right? Because the way that I subtract a negative is by adding. So I'm going to have 3. If I'm trying to find the length of BC, again, I would do what I just did before. So 3 minus 1, which is 2. Now, using the information that I collected above, how could I find the length of AC? Well, B is right in between AC. I know that AB was 3, and then I know that BC was 2, so I can add these guys up, and I get 5. And this leads us to our segment addition postulate. If AB is between AC, if B is between A and C, then AB plus BC equals AC every single time. And so basically the two little pieces will add up to the whole. That's how I like to say it. All right, now let's see how we can apply this. So B is between A and C in the following diagram. All right, so if the length of AC of the entire thing here is 10, and the length of AB is 4, what is the length of BC? Okay, so this one, a lot of people could do it in their head, but I want you to apply the theorem because they're going to get a little bit more difficult. So we know that if B is between AC, then AB plus BC equals AC, equals the length. So what have I been given? I have been given AC, which is 10. I have been given AB, which is 4. And so how could I figure out what the length of BC is? Well, I can do inverse operations, and I can subtract here. So BC is going to be 6. And I know that a lot of people could have done this just by kind of looking at the picture and subtracting, and that's okay, but I just want you guys to see where we're headed because they are going to get a little bit more difficult. So now here we have an algebraic expression. So if M is between N and O, find NO. Okay, so we are going to use our segment addition postulate here that says that NM plus MO equals NO. Right? So I know that NM, according to this picture, is 17. I know that MO, according to this picture, is 3x minus 5. And then I know that NO is 5x plus 2. So what I'm going to do is I'm going to solve this out. So first, let's simplify this side by combining like terms. So I have 17 minus 5, and that's going to give me 12. And then now I can go ahead and start solving by moving my x's over to one side. So this is going to be a minus 3x, and so I have 12 is equal to 2x plus 2. We can go ahead and subtract 2 here. And so I'm going to have 10 equals 2x. Divide both sides by 2. And we have that 5 is equal to x. Now, we are not finished with this problem because this problem is not asking us to find x. Always read the problem one more time before you answer a problem in geometry because geometry is a lot of more application. So what we need to do is we need to plug this back in to find NO. So if you look here, the equation for NO is the big line. So NO is equal to 5x plus 2. So what I need to do is I need to plug in my x, which is 5. And so I have 5 times 5, which is 25, plus 2, which is 27. So the segment NO is 27, and it can have units, right? Inches, centimeters, so forth. But they didn't tell us here in this problem. Okay, so my next problem here, they're telling me that BC is 22. They're telling me that AB is 4x plus 2. And then the entire line segment, AC, is 8x plus 8. So according to my postulate, the equation that I can write is that 4x plus 2 plus 22 equals 8x plus 8. Now we can go ahead and solve this out. So first I would add up the 2 and the 22. So I have 4x plus 24. Move my x's over to one side. So I'm going to have 24 is equal to 4x plus 8. Subtract this 8. So I'm going to be left with 16 is equal to 4x. And then divide both sides by 4, and I have that 4 equals x. Now, again, the question is not asking me for x, it's finding me to find AC. So I need to plug it back to AC. So AC is going to equal 8 times 4 plus 8. 8 times 4, I'm going to have 32 plus 8 is 40. And again, if you plug it back into A, B, and BC, your number should add up to 40. Always kind of make sure of that. All right, so now let's do the last problem. So here, it says in this diagram, AB is 3/4 of AC. AB equals 18 centimeters. Well, I know this equation right here. AB is 3/4 of my entire line segment, right? And I know that this is also 18 centimeters. And I know that it's 3/4 of the entire line segment. I know these two things. So these are two pieces of information that are talking about the same line. So what I can do here in this equation is I can swap out the AB for what it equals. It equals 18 centimeters. Okay, and then now I can go ahead and solve for AC. I solve for AC, I have to get rid of multiplying by 3/4, right? By dividing by 3/4. But instead of dividing by a fraction, right, we always say just multiply by the reciprocal, 4/3. This will undo here, and then I can do this on the other side. So now when I do this, I always like to divide first. So 18 over 3 is a 6. And 6 times 4 gives me 24. So this is just like our fraction work that we did in the beginning. Now we are not done because the question is not asking me for AC. So I know that AC, the entire line segment, is 24 centimeters. I know that AB is 18 centimeters. So I need to find this little piece right here. So if we use our segment addition postulate, right, that says that AB plus BC equals AC, I can go ahead and basically, right, subtract in this case, right? Because if this is 18, I'm trying to find BC, and this is 24, I can go ahead and subtract 18 from 24, and I'm going to have that BC equals 6 centimeters. All right, another way that you could have thought about this is if this was 3/4 of the entire line, then BC would be 1/4 of the entire line, right? And then you could have figured it out that way, but you would have still had to figure out what AC is first. Okay, so now this is the end of this video, so make sure that you have taken good notes on this. And yes.